Hello again, everybody. So now we're going to see the for statement. The for statement is one of the loops statement that Python has. One of them is the for statement, and the other one is the while statement. Okay, that we will see it in a while. Okay, so the for statement. The for statement is a compound statements that we saw before what compound statements were, that iterates over the elements of a sequence or an iterable object in the same order that they appear in the sequence. Okay, so let's see what this means with this, with the syntax and with an example later. So the syntax for writing the for statement is this one. Okay, we have to write first the for, okay, for target in iterable, and then we have this column here. Okay, this column here, remember that it means that it's going to run these statements which are indented. Okay, they have an indentation here. This is the block of the for code, and then of the for statement. I'm sorry. And then we have the else statement, which is optional. Okay, and is going to have also its own block of statements. So what does this target, iterable, and statements mean? Okay, target is just the name of the variables that are going to store the values of the iterable. Okay, so this is going to, if iterable has a sequence of values, then these values are going to be, these values are going to be iterated, and in each iteration, the target is going to get the value of this iterable in that position. And with this value, this is going to be run with these statements. So these statements may or may not, sometimes not, may be related to this target value over here. And in the end, after running all these statements in the all the iterations, okay, in the end, after the iterable has finished, okay, the sequence has ended, then we are going to run the else statement, which is, as I told you, is optional, an optional statement, and it's going to do whatever it's going to do here. Okay, so these iterables can be any variable that can be iterated, like a list, a NumPy array, a dictionary, a string, a range. Okay, range is an expression that returns an iterator over an integer steps. Okay, so this is like np.arrange, but in Python, and not returning an array, but only an iterator. So this is what some examples of the iterable. Okay, and well, the target is just, as I just told you, it's a variable or a list of variables that take the value of iterable on each iteration. So we are going to see the first example. Okay, the first example, we are going to iterate over the letters of a string. Okay, we have this sentence, which is hello Peter, how are you? And we have these two variables, which are vowel and consonant, and they are going to store the number of vowels and consonants that we're counting in this sentence. So, fuck, this is wrong. Okay, if letter dot lower. Yes, so now we have for letter in sentence, if letter dot lower is in this string over here, okay, then we are going to count a vowel more. Okay, one more vowel, and this is, I'm using here the syntaxes of augmented assignment, which is equivalent to this statement. Okay, so this statement over here, this is called an augmented assignment. You don't have to know how it is called, okay, but the main point is that this expression is, this statement is exactly the same as this statement over here, exactly the same. So we have if letter dot lower in this is a vowel. Basically, if this is a vowel, I'm going to count one more vowel, and else if, okay, else if this letter dot lower is in this other set of characters, then we are going to count one more consonant. Okay, and I'm using again the augmented assignment. And okay, so we are going to count all these letters and consonants from this sentence, and in the end I'm going to print there are the number of vowels and the number of consonants. So in this case, and remember, for each iteration of this loop, sentence is composed by a string of characters, okay, a sequence of characters. So the first letter is going to be this upper H. Okay, the second letter, the second value of letter after in the second iteration is going to be this lower E. The third value of letter in this iteration, okay, is going to be a lower L, and then another lower L, then an O, okay, then a space. Notice that in the space, nor this condition nor this one is neither this one is fulfilled, so it doesn't do anything basically. Okay, and in the end it's going to print this. So if I run this piece of code, well, it says that this sentence has 9 vowels and 10 consonants. Okay, and in the previous case, in the previous piece of code, this wasn't right. Okay, this was wrong because I had this over here, this only letter. So the point is that letter distinguishes between upper and lower case. So if this Peter and this P from Peter and this H from hello are not going to be counted here. So what I need to do is to make this letter lowercase and then compare to see if it is in this sequence of letters. All right, and that's it. This is how to iterate in this case in a string, okay, in the characters of a string. We can also iterate in the items of a dictionary. So if I iterate in the items of a dictionary, I have this dictionary over here, my dict, which is composed by these four items. Okay, if the first item is Amazon, which has a value of 62, then Microsoft, which has a value of 20, MathWorks has a value of 3, and Google has a value of 87, which can be some index related to these companies. Okay, and now I'm going to iterate over these items. In order to do that, well, first of all, I'm going to print these items so you can see what these items look like. Okay, these items look like this. This is going to return some kind of a list. This is not exactly a list. Okay, it's an object of the type dict items, and it's going to have a list, and inside the list it has the tuples of the key and the value of each of the items. Okay, so I have the first item is going to be a tuple with the name of the company and then the value of the index related to this company. Then I have Microsoft with the value 20. Then I have the MathWorks. Notice that all these keys are strings. They don't have to be strings. Okay, in this case they happen to be strings, but they could be numbers too, or well, any other thing that can be ordered. And Google has the value 87. So if I want to make an iteration, to make a loop, to write only the companies that have a value greater than 50, in this case, then what I'm going to do is write this for loop. Now I'm going to have for key val in my dict.items. Why do I have now 2 targets? Okay, notice that this part over here corresponds to the target side. Okay, so I have here instead of only 1 target like I did before for the letter in sentence, now I have 2 targets. And why is that? Because each of the items of the dictionary is composed by two things. It's a tuple with 2 things. Okay, so these 2 things are going to be assigned to the value of key and the value of val. So key in the first iteration, key and val in the first iteration these are going to take the value. Key is going to take the value Amazon, and val is going to take the value 62. This for the first iteration. So if val is greater than 50, then it's going to print the key and the value in this format. And if not, then it's going to do anything. I mean, it's not going to do anything, okay? It doesn't do anything. And then I go to the next iteration because I run all these statements in this block of code. Notice the indentation, okay? Notice that I have here a nested indentation, because a nested block, because I have here a block with four indentations, 4 spaces, I'm sorry, and here I have the block of the if statement, which also has 4 spaces. In the next iteration, now key val are going to take the second values of this dictionary, which are Microsoft and 20. So key is going to take the value Microsoft and val is going to take the value 20. Now, since val is smaller than 50, in this case, this is not going to be printed. So Microsoft is not going to be in the printed list of companies that I'm writing here, and so on. So when I run this loop over these items, over the items of my dict, then the result is printing Amazon 62 and Google 87. That's it, because Microsoft 20 and MathWorks 3, and MathWorks 3 are all, this value are smaller than 50. These values are smaller than 50. And that's it. Okay, so that is how a for loop works with two targets. In this case, we only had one target. In this case, I have 2 targets. We can use as many targets as we want, as long as the iterator here returns the same amount of values. So if I have here 3 values, then I need on the right side an iterator that on each iteration is going to return 3 values. Okay? Another example over here. So in this case, I'm going to make the iterations of a dynamical system, okay, a discrete dynamical systems. You have already seen dynamical systems in mathematical methods, and what we're going to do is with this simple, very simple linear dynamical system, okay, with this the values of A and B, okay, this is a non-homogeneous yes, well, this is not autonomous. This is autonomous, yes, I'm sorry, this is an autonomous dynamical system, but it is non-homogeneous since this has a constant B, okay, and we have here the constant that multiplies the values of x is A. So I'm going to compute the value of x 10, okay, for t equal to 10. The constants A and B are going to be 0.5 and 10. Notice here I'm using the assignment statement with commas, okay. I can make multiple assignment in this way. Now I'm assigning the number of iterations that I'm going to do and the starting value. So the starting value is going to be 50. I'm going to print the starting value, and then I'm going to print all the other values until number 10. Okay. So in this case, I'm using the range expression. Okay, range expression is exactly the same as np dot arrange expression. Okay, the NumPy arrange expression, which returns, in the case of NumPy array, it returns an array that goes from 0 to n, or it can go from well, for other syntaxes here you can add here more numbers, and there are a variety of ways of using it. In the case of range, this is only going to work with integer numbers. Okay, other things that are not integer numbers are not going to work. And it also works for, instead of starting from 0, it can also start from another number, okay? And we can also say that the steps go backwards, so we can say that the step is negative, or the step is 2, 3, whatever. So it basically works like NumPy arrange, but with integer numbers, and this doesn't return nor a list nor an array, but an iterator. Okay, so we can iterate over the values of this range. So in this case, I have the first statement. I have that the target is called n, and the target is called n and is in this range. Okay, so this range starts from 0 and ends in n minus 1. Okay, upper n minus 1. I have a lower n for the value that is taken this in each iteration, and n for the size of this range, and upper n for the size of the range. So in this case, I'm going to use this iterator, okay, this iterator over here. So I'm going to compute the new value in terms of the old value, okay, and then in the end I'm going to print, in the end of the block, I'm going to print the computed value. So I'm printing this one, okay. And so for the first iteration, the value of lower n is going to be 0. So this is going to print 1. Okay, the first print corresponds to this print over here. Okay, so this first print is this first line here. The second print is inside the loop already. So here we have the first print of the loop. Then the second print of the loop is going to be this one and this one and so on. So in the end, after 10 iterations, I have this value of x. Okay. Yes, as this is a very simple way of doing, well, of computing the elements of a dynamical system. Okay. And now for the last thing that we're going to do in the for statement, well, this is another kind of a statement of the for loop, which is an expression generator. Okay, we can generate expressions using the for loop in a one-liner. Okay, so these are some examples. So we can create a list. This is an expression generator because it generates things like lists, dictionaries, sets, and I think that's it. So here I have a list generator. Okay, this is between square brackets. Okay, the for expression is between the square brackets, so the result is going to be a list. And in this case, what this iterator does is the following. This is going to return a list of these expressions where these expressions are the result of this for loop. So this is more or less, this is equivalent, and I forgot to make to write the equivalent code. This is equivalent to make an append in this for loop. Okay, so in this case, I'm writing this. Well, I'm going to explain all these things, and then I'm going to go for the examples. Okay. So we have here. No, but yes, I'm going to write this expression. Okay. So this is equivalent to this thing. I have my list, the empty list. I have an empty list here, and then I write the for loop. And the for loop is going to be for target in the interval. Okay, and then the column, and then I have to make my list dot append and this expression over here. Remember that an expression returns a value. So if I have here an expression, this is going to return some value, whatever it is. And this is equivalent, the result of this list is equivalent to this for loop. But sometimes this is more readable because it's in a single line and you can understand easily what it does. And in the case of a dictionary, we can also generate a dictionary. In this case, we have that my dictionary is going to be the result, and notice that I'm using here curly brackets, okay, curly brackets, and with the syntax of the dictionaries creation. Okay, I have here the expression that is going to be the key, and here I have the expression that is going to be the value. And this is going to be these keys and these values are going to be the result of these for. Okay, are going to be, it's like the block statements of the for statement here. Okay, yes, that's it. So this is equivalent to this other expression. Well, to this statement. Okay, for, and this is the same for target in interval. Okay, this is exactly the same. And now I have, yes, first I have to make an empty dictionary. Okay, so my dict in this case is an empty dictionary, and then I'm going to add all the items of this dictionary. So my dict, and this I have the key expression. Okay, this is going to be equal to the value expression. Okay, and the result is going to be exactly the same in this case and with this line of code. And we can also use filters. Okay, so if we use filters, what we have is that instead of doing this for all these iterables, okay, instead of computing this this part of the code and this part of the code for all the values of the iterables, this is going only to be done if the target fulfills some condition. Okay, so this is going to be done only for some condition that has to fulfill the target. Usually this condition is related to this target. Okay, and also usually this expression is related to this target. Okay, in all these cases, expressions are and conditions are related to the target, to the value of the target in that iteration. Okay. So, well, in this case, I'm writing here an expression, okay, the same as I did before. So this is what we have now, okay, the equivalent expressions. I also have here some equivalent expressions, but I'm going to write them in the examples, okay, so you can see how it works. So in this case, in this example, I have in this list, I have a list of tuples. You can see these tuples, and each tuple has the first element of the tuple is going to be a city name. The second element is the longitude value of this city, okay, and this is going to be the latitude where the city is placed, okay. So here we have a list for different cities of the name of the city, the longitude and the latitude of those cities. So to make a dictionary of the form city and then the latitude and the longitude of this city, I can do this. Okay, so this is what I'm doing here. I'm saying cities is going to be a dictionary, okay, notice the curly brackets, a dictionary where I'm going to write the city and then in a tuple the latitude and the longitude of this city. So for this is going to be done for, and these are related to the targets, okay, so the targets are going to be city, lat and long. And these are the targets that belong to lat long list. Remember that lat long list is a list that returns in each iteration. This is going to return 3 values because this tuple has 3 values. So I can go to this, since I know that it has 3 values, I can specify 3 targets for this iteration. And then on each iteration, this is going to take these values. Okay, so this is and this is the result. Okay, notice that this is the result, and this is exactly going to be the same as doing this. I have the lat long list is going to be the same. I have the cities. I'm going to write as an empty dictionary. I'm going to write the for loop for city lat long in lat long list, and then I write the column. And then indentation occurs magically because I have a very smart editor that knows that I need to write here some piece of block code. And then I'm going to do cities of city equal to the tuple lat long. Okay, and this is going to be exactly the same. And if I return cities, notice that I have exactly the same values as I did before. Okay, I think that this is, when you're reading code, when you're writing code, maybe it's more or less the same. I didn't time it, so I don't know exactly how this works, but we can time and look for the differences. So if I time this, and this is a magic function of IPython, okay, and this works for Jupyter and for Python. So if I do time it, and by default yes, I'm going to do this over here, okay, into this, time it, and then this statement, I think it works, yes. Now it's thinking, it's making some iterations. So I'm going to have here, this is the time that each of these, that on average this statement is evaluated, which is 491 nanoseconds, okay, so this is less than half a millisecond. And now I'm going to time this over here, and I'm using this thing here, and this is doing the same. This is going to do the same as before, and this is, well, this is very similar. It's also less than half a millisecond. So this is not so much about the execution time, but the readability mainly, yes, because this is in just a one line, and it's very comprehensible what it does. Okay, so another example, I'm going to make a dictionary, and now instead of using 3 targets, I'm only going to use 1 target. So in this case, notice that what I'm doing is assigning, again, I'm going to iterate to obtain a dictionary, okay, and the dictionary is going to be like this. In this case, I was using 3 targets, city, lat, and long. So I had lat long list. But in this case, I'm going to use just 1 target. So since lat long list on its iteration is going to return a tuple of 3 elements, then row is going to be that tuple. So on its iteration, row is going to be a tuple of 3 elements. The first element is going to be the name of the city, the second element is going to be the longitude, and the third element is going to be the latitude. Okay, so notice that in this case, I'm also adding a condition. So I'm only going to add this element to the, well, these are the elements of the dictionary, okay? So row 0 is going to be the name of the city, and then this tuple, which is row from 1 until the end, this is just like making a tuple, okay, a parenthesis. A parenthesis with row 1 and row 2, okay, a tuple with these 2 elements. And this is only going to be done if the longitude is negative, okay, because I'm going to make a dictionary with only cities in the west. Okay, remember that the west is to the left of the Greenwich, to the left of latitude. Meridians, that's it. So to the left of the Greenwich meridian, we have negative latitudes, and to the right of the Greenwich meridian we have positive latitudes. In this case, since I want to stay in the west of the Greenwich meridian, I'm going to keep only the negative longitudes. I mean longitudes, not latitudes, but longitudes. So here in the end, what I have is that from this set of cities, the only ones, these are all from Spain, the only ones of this that are to the left of the Greenwich meridian are Madrid, Valencia, and Badajoz. Okay, Madrid, Valencia, and Badajoz that all have negative value of this longitude. So we can do many things with this kind of for expression, okay, for expression generators. And that's it. In this case, notice that I've done the same, but instead with a list, well, not the same, okay? I'm making a list of the cities that are in the west, okay? Starting from the same lat long list that I had before, now I'm only returning the names of the cities in a list. So in this case, I'm using square brackets, okay? And here I'm using the square brackets, and now I'm keeping, just like before, but I could do this also with 3 targets, okay? But I'm using just like before, only 1 target that is going to store the whole tuple of lat long list. And the condition is exactly the same as before, and now only row 0 is going to be returned in this expression. So what I obtain are the names of the cities. Okay, and that's it for the for statement.